Hey everyone, and welcome to Pop Culture Pulse. Today we're diving into some seriously cool tech. Stuff that sounds like it's straight out of sci-fi.
Mm.
We're talking about robots, but not just any robots. Robots with a sense of touch.
Yeah, it's pretty wild stuff. We're talking machines that can feel, pressure, texture, even temperature, just like we do.
Exactly. So we're looking at some cutting-edge research from Meta's fundamental AI research team.
Hmm?
They're also known as FAIR. You might know them from, their work on social media. But these guys are also doing some really groundbreaking stuff in AI and robotics.
Yeah, and their latest project is all about giving robots that sense of touch. They've developed this whole suite of tools, and it could totally revolutionize how robots interact with the world.
Okay, so before we get into the nitty-gritty, can you give us just like a quick overview of why this is such a big deal? I mean, robots have been around forever, so what's so special about giving them a sense of touch?
Well, it's all about expanding what they can do. Think about it. We use touch for so many things, from delicate tasks like, handling a fragile object to understanding what different materials are like.
Right, like knowing if an avocado is ripe just by squeezing it.
Exactly. Up until now, robots have mostly relied on vision to navigate and interact with the world. But vision isn't always enough for more complex tasks. Giving them a sense of touch opens up a whole new level of dexterity and understanding.
So tell me more about these tools that Meta has developed. What are we talking about here?
Well, one of their most impressive creations is called Sparsh. It's a Sanskrit word that means touch.
Okay, I like it already. Cool name.
Yeah, it really is. And the tech itself is even cooler. Sparsh basically lets AI interpret tactile data, similar to how our brains process signals from, our nerve endings.
So it's not just about having sensors. The AI actually has to understand what those sensors are telling it.
Exactly. Sparsh can tell the difference between textures, detect tiny changes in pressure. It can even understand how an object is moving just by touch. It's like giving a robot the ability to feel its way around in the dark.
Wow, that's amazing. So what about the hardware? What kind of sensors are we talking about?
Well, they've developed a few different types of sensors, each with its own capabilities. One of them is called Digit 360. It's a robot fingertip that they created with a company called Gelsite.
A robot fingertip that's pretty specific. What makes it so special?
It's all about the sensitivity.
Mhm.
Digit 360 has this array of tiny cameras that capture super detailed images of the surface it's touching.
So it's not actually feeling pressure directly. It's using cameras to see how the object changes shape under pressure.
You got it. And the level of detail it captures is incredible. It can even detect microscopic imperfections on a surface.
So could this Digit 360 tell the difference between like a real leather wallet and a fake one?
Absolutely. And it could do it just by touch without needing to see any logos or stitching.
That's wild. So if Sparsh is the software that interprets the data, and Digit 360 is this super sensitive fingertip, what other tools are in Meta Suite?
They've also developed this sensor network called Plexus. It was created in collaboration with Wonik Robotics. And unlike Digit 360, which focuses on a single point of contact, Plexus is designed to give a robot hand a more holistic sense of touch.
So it's like a network of sensors that cover the entire hand.
Exactly. And that allows for a much more nuanced understanding of objects. A robot hand with Plexus can adjust its grip to the shape and texture of an object, even if it's irregularly shaped or fragile.
That sounds incredibly useful for tasks that require a really delicate touch.
Exactly. Think about handling delicate components in electronics manufacturing or assisting with surgery where precision is super important.
This is really starting to blow my mind. But let's go back to basics for a sec. How do these sensors actually work? What are they made of? And how do they turn physical pressure into data that a computer can understand?
Well, the exact materials and mechanisms depend on the sensor, but generally they rely on principles like piezoelectricity or capacitance.
Okay, maybe ELI5 on those terms?
Sure. Piezoelectricity is the ability of certain materials to generate an electrical charge when you put mechanical stress on them. So, for example, if you squeeze a piezoelectric sensor, it produces a voltage. And that voltage is proportional to the amount of pressure applied.
That's pretty cool. And capacitance?
Capacitance has to do with a system's ability to store an electrical charge. A capacitive sensor basically measures the change in capacitance between two conductive plates as the distance between them changes because of pressure or touch.
So basically, these sensors convert physical interactions into electrical signals. And those signals can be interpreted by a computer as data about pressure, texture, and movement.
Exactly. And thanks to advancements in AI and machine learning, those signals can be translated into incredibly detailed information about the objects being touched.
That's fascinating. So we got the software like Sparsh that interprets the data. And we've got the hardware like Digit 360 and Plexus that capture the information. But let's talk about the real-world applications. Where is all this technology headed?
The possibilities are really vast. One of the most exciting areas is medicine. Robots with a sense of touch could assist surgeons with incredible precision, potentially leading to less invasive procedures and faster recovery times.
I can see that. And what about beyond medicine? What other industries are ready to be disrupted by robots with a sense of touch?
Well, manufacturing is a big one. Robots with tactile sensitivity could assemble delicate components much more accurately than humans, minimizing errors and improving efficiency.
That makes sense. And what about tasks that are dangerous for humans, like handling hazardous materials or working in extreme environments?
Exactly. Robots equipped with these sensors could be used in those situations, keeping human workers safe while still completing critical tasks.
This is all incredibly exciting, but I have to admit it's a little unsettling too. I mean, robots that can feel, it's like something out of a science fiction novel.
It's definitely a big leap forward in robotics, and it does raise some important questions about the future of work and the relationship between humans and machines.
Well, we'll definitely have to dive into those questions in more detail. But for now, let's take a closer look at some of these specific ways this technology is being developed and the challenges that researchers are facing.
Sounds good to me. Let's start with Meta's work on replicating the human sense of touch across an entire robotic hand with their Plexus system.
What complex it is? Tell me more about how this sensor network is designed and what makes it so unique.
So Plexus is really pushing the limits of robotic touch. It's not just about the individual sensors. It's more about creating a network that kind of mimics how our skin and nerves work together.
So it's not just about feeling pressure at one point, it's about understanding the whole object, right?
Yeah, exactly. That's the idea. Like imagine holding something delicate, like an egg. You don't just squeeze it with one finger. You use your whole hand to spread out the pressure, and Plexus lets a robot do that too.
That makes sense. But how does it actually work? How do you connect all those sensors and get them to talk to each other?
It's pretty complicated, but basically they use this flexible, interconnected array of sensors, and they're embedded in this soft, skin-like material. This lets the sensors conform to the shape of whatever they're holding.
So it's kind of like a glove with sensors all over
You
it.
could think of it that way. And each sensor is constantly gathering data about, pressure, texture, even temperature, sending that information to a central processing unit.
And that processing unit is what figures out the data and lets the robot adjust its grip.
Exactly. It's like the robot's brain is getting a constant stream of feedback from its hand, so it can make adjustments in real time to make sure it's got a safe and secure grip.
That's incredible. So with Plexus, a robot could pick up an egg without breaking it, or handle a delicate piece of equipment without damaging it.
Exactly. That's the goal. And it's not just about being gentle, it's about adapting. A robot hand with Plexus can handle different shapes and sizes, even if it's never seen them before.
That's a huge advantage over the usual robotic grippers that are designed for one specific task.
Definitely. Plexus opens up a whole new world of possibilities for robots in manufacturing, logistics, even healthcare.
Speaking of healthcare, you mentioned robots with a sense of touch could be used in surgery. Can you give me some examples of how that might work?
Sure. Imagine a robotic arm helping a surgeon during a really delicate procedure.
Hmm.
With Plexus, that arm could feel the subtle differences in tissue density, giving the surgeon important feedback in real time.
So it's not about replacing the surgeon, it's more like giving them an extra set of hands.
Exactly. It's about teamwork between humans and robots to get the best possible outcome for the patient.
That makes sense. But I have to admit, the thought of a robot operating on me is a little scary, even with a human surgeon in charge.
I get it. It's natural to feel a bit uneasy about robots doing things that humans have always done.
Especially when it comes to something as delicate and important as surgery.
Of course. But remember, these technologies are still being developed. There are strict safety measures in place, and any use of robots in surgery would be heavily regulated.
That's good to know. Let's shift gears for a moment. You also mentioned manufacturing and logistics as potential areas where robots with touch could be a game changer.
For sure. In manufacturing, these robots could be used to put together complex products with way more precision and efficiency, and that could potentially lower costs and improve quality.
And logistics. How could touch help robots there?
Well, think about all the stuff involved in packing and shipping. Robots with a sense of touch could identify different items, handle them carefully, and even pack them into boxes in the most efficient way.
So they could potentially replace human workers in warehouses and fulfillment centers.
It's possible, but it's more likely that they'll work with humans at first, helping them out and letting them focus on more complicated tasks.
That's a more optimistic way to look at it.
Yeah.
It's not about robots taking over. It's about humans and robots working together to be more efficient and productive.
Exactly. That's one of the key things to remember here. These advancements aren't about replacing humans, they're about making us better and creating new possibilities.
I like that. But let's not forget about the other senses we've been focused on: touch. But what about smell and taste? Are those being explored too?
Absolutely. Researchers are making progress in replicating those senses too, though they do have unique challenges.
Okay, tell me, what are some of the hurdles researchers are facing when it comes to giving robots the ability to smell and taste?
Well, smell and taste, they're super complex, you know. They rely on detecting and understanding thousands of different molecules. And that's a tough job for a
So
machine.
we have sensors for light and sound waves. That's pretty easy. But making sensors to accurately pinpoint and tell the difference between thousands of smells and tastes, that's a whole different challenge.
Exactly. It's not just about the sensors themselves, it's also the AI that needs to process all that data and make sense of it.
All right, just because a sensor picks up on a molecule doesn't mean the robot knows what that smell or taste actually is.
Right, like a robot might be able to sense those compounds that make up the smell of coffee, but could it tell the difference between different kinds of coffee? Or like fresh brewed versus stale coffee?
Good point. It's one thing to detect the chemicals. It's another to actually understand all the little details and complexities of those smells and tastes.
Yeah, and that's where the real challenge is. We're still a ways away from robots experiencing smell and taste like we do.
But even with those challenges, researchers are making progress, right? You mentioned some companies are working on this.
That's right. There are companies like Osmo, for example. They're developing AI noses. These noses can identify and even recreate scents.
So you're saying in the future we could have robots that can not only smell a rose, but also make a perfect copy of that smell.
That's the idea. And there are so many cool potential uses. Robots that can detect gas leaks or dangerous stuff. Robots that can help create new flavors and perfumes.
It sounds like something out of a movie, but it's becoming more and more real. What about taste? Any exciting developments there?
That's even trickier than smell. Taste involves not just our taste buds, but our sense of smell too, and even our emotions.
So it's not just about those basic tastes: sweet, sour, salty, bitter, umami. It's about how all those tastes work together with our other senses and our own preferences.
Exactly. Replicating all that in a robot is super complicated.
But I imagine there could be some cool uses if we could figure out robotic taste.
Absolutely. Think about robots that could help chefs create new recipes, or robots that could check the quality of food.
Or maybe robots that could be like personal sommeliers recommending the perfect wine.
The possibilities are pretty much endless, but right now we gotta admit that giving robots smell and taste is still a long way off.
But hey, even though those senses might be further down the line, the advancements we're seeing in robotic touch are already pretty amazing.
Oh yeah, they are. I think we should take a moment to appreciate the incredible ingenuity and creativity behind all of this.
For sure, it's awesome to see how researchers are pushing the boundaries, always finding new ways to connect humans and machines.
And as this technology keeps evolving, we need to be talking about the ethical and societal implications.
Absolutely. We need to make sure these advancements are used responsibly and for the good of everyone.
Well said. It's an exciting time, but it's also a time to think carefully and have important conversations.
This has been a fantastic conversation. Thanks so much for joining me today and sharing your expertise on this amazing topic.
My pleasure.
And to all our listeners, thanks for tuning in to Pop Culture Pulse.